Okay, we need to finish this section by constructing the graph of secant and cosecant and then doing the translations on them like we've done with the other four trig functions. But instead of making a table of values like we've done for the first three, remember what we did to get the graph of cotangent from the graph of tangent. I'm going to do the same procedure here. So the example says use the graph of sine to construct the graph of cosecant. Well, there's a good chance for us to review the sine graph, so I'm going to draw the sine graph and then use that to get the cosecant graph. Right? So remember, for the sine, your basic sine graph, y is sine x, something important happens every pi over 2 on the x-axis. And then minus pi over 2, minus pi, minus 3 pi over 2. And remember, the range of the sine graph is from -1 to 1. So this is your basic scale here. And you always ask yourself at this point, what does the original sine graph do on the y-axis? It crosses at 0, 0. And as you head to the right, the original sine graph goes up. It increases. So this is the middle, high, middle, low, high, middle, low, middle, high. Okay, so here's my sine graph. Okay, so this is old, we know this. Okay, so here's sine x. Okay, now I want to construct the cosecant graph from this. Now remember, sine and cosecant are reciprocals of one another. Okay, so for example, if you knew sine of theta was 2/3, cosecant of theta would be 3/2. It'd be the reciprocal. Okay, notice if I do the same thing here. Suppose sine were 1. Okay, suppose sine of theta were 1. What would cosecant of theta be? Well, cosecant's a reciprocal of sine, so cosecant of theta would also be 1. So notice everywhere that sine is equal to 1, cosecant will also be 1. Okay, so I'm going to do the cosecant graph here in black. So everywhere sine is 1, cosecant will also be 1. Okay, so sine of pi over 2 is 1, so cosecant of pi over 2 is 1. Sine of minus 3 pi over 2 is 1, so cosecant will also be 1. Likewise, wherever sine is equal to -1, cosecant will be the reciprocal of that, which is also -1. Okay, so where is sine equal to -1? Sine of minus pi over 2 is -1, so cosecant of minus pi over 2 will also be -1, and same thing over here. Okay, so far I have 4 points and they match the sine graph. Now what about where sine is equal to 0? Okay, where sine is equal to 0, what is cosecant going to be? Well, the reciprocal of 0 is undefined, so cosecant of that angle would be undefined. So everywhere sine is 0, cosecant's undefined, and it shouldn't surprise you that we're going to have vertical asymptotes there. So sine of -pi is equal to 0, so we have a vertical asymptote there. Sine of 0 is 0, so cosecant is undefined, well, vertical asymptote there, and likewise at pi. Okay, so far so good. Now we just have to fill in the details in between. Remember when we were arguing, going from tan to cotan, about small values versus large values? For example, suppose I pick an angle here just a little bit bigger than 0. Notice sine of that is small, right? I didn't have to move up very far on the along the y-axis to get that y value. So sine of that angle would be very, very small. Well, what's the reciprocal of a tiny, tiny number? Like 1/1,000,000. The reciprocal of that is 1,000,000. So where sine is tiny, cosecant is going to be large. Okay. Same thing over here, right? If you pick a value just to the left of pi, sine of that is tiny, so cosecant of that, the reciprocal will be large up here. And so you see what's going to happen is you're going to have what I call a cup. Okay? And likewise, and same thing here, right? And something over there. Okay, now what about the values here? Right? If I pick say a value here just to the right of -pi right here, notice sine is tiny but negative, like -1,000,000th. So the reciprocal of that for cosecant would be -1,000,000, way down here. And same thing right here, right? So you have these cups going this way. And then same thing over here. Okay, so what I have there in black is the cosecant graph. Okay. Okay, let's look at the domain of the cosecant graph. Remember, the domain of sine was all real numbers, and the range was between -1 and 1 inclusive, including -1 and 1. What's the domain of cosecant? It's all real numbers except minus pi, 0, pi, 2 pi, 3 pi, etc., and in the negative direction as well. Now, what's the range of the cosecant function? What y values do we get? We get 1 and larger, or -1 and smaller, right? We don't get any values strictly between -1 and 1. But that makes sense, because a sine's always between -1 and 1, like 2/3 or 7/8. What's the reciprocal of those numbers going to be? The reciprocal of 2/3 is 3/2. The reciprocal of 7/8 is 8/7. Okay? So it makes sense if sine is between here, the reciprocal of those values will be out here. So that makes sense. Okay, now oh, and be careful, these are not parabolas. Students will always say this is a parabola. Remember, parabolas go up and out forever. These are trapped between two vertical asymptotes, so they're not parabolas. Okay, let me get rid of this. Okay, because we don't want to have to do this every single time we're interested in the cosecant graph. So how do you construct the cosecant graph from scratch, okay? Every pi over 2, something important happens. So if I was going to do cosecant from scratch, this is what I would do, right? Something important happens every pi over 2. That has been the case for all of our graphs. Okay? And we know that 1 and -1 are important. Okay? And then you have to realize what's the pattern with cosecant. It alternates asymptote point, asymptote point, asymptote point, just like the tangent and the cotangent graphs did. But here the points are not on the x-axis. For tan and cotan, they were x-intercepts. Right? Now, what did the cosecant graph that we just constructed do on the y-axis? The cosecant graph had a vertical asymptote. Okay? So cosecant has a vertical asymptote. And you know it alternates asymptote point, asymptote point. So it's asymptote point, asymptote, asymptote point, asymptote. And now you have to remember that we have these cups. Okay? So there's an up cup and a down cup. You just have to remember, is the up cup here or here? Okay, for the cosecant graph, your basic cosecant function, the up cup is to the right. Remember, the sine graph went to the, when you went to the right, it went up. The cosecant graph, when you go to the right, it goes up. So that's the up cup, which means the down cup is over here. And then it's going to be a down cup here and then an up cup, etc. Okay, so every pi over 2, something important happens. -1 and 1 are your cutoff values for your cups, the bottoms of the cups and the tops of the cups. The cosecant graph has a vertical asymptote on the y-axis, and when you go to the right, it's the up cup. Okay, so there's your cosecant graph. Now, what do you think the period of this cosecant graph is? Realizing that, again, after you have a down cup, and then you're going to have another up cup. Right? Well, how long on the x-axis does it take before the pattern repeats? From minus pi to pi, you have a down cup and an up cup, and when you move it, you have a down cup and an up cup. And I can't get any smaller because you have to get an entire up cup and an entire down cup. So it looks like the period of the cosecant graph is 2 pi, which should not surprise you because that was the period of sine. And now, how many pieces am I going to use to sketch this? Just like with sine, right? With sine, we did it with 4 pieces. One of the pieces here, half the cup, half the cup, half the cup, half the cup. There's the 4 pieces. Okay, so the graph is periodic. The period's 2 pi, and we're going to graph it with 4 pieces. Okay, let's do the same thing for cosine to get the secant graph. Okay, so let's sketch the cosine graph, and we're going to argue the exact same thing we did before. So every pi over 2, I'm sketching the cosine graph here. So every pi over 2, something important happens with the cosine graph, and we're going from -1 to 1. Now remember, the cosine graph crossed the y-axis at 1, that was a high. So you have middles, and then lows, and then the middles again, the zeros. Okay, so here's cosine. This is nothing new. Okay, I'm going to do the exact same argument I did before getting the cosecant graph to get the secant graph. Everywhere cosine is 1, secant is going to be 1. Everywhere cosine is -1, secant will be -1, because the reciprocal of 1 is 1, the reciprocal of -1 is -1. Okay? Now, everywhere cosine is equal to 0, secant is going to be undefined. So we're going to have vertical asymptote, vertical asymptote, vertical asymptote, vertical asymptote. Everywhere cosine is small and positive, the reciprocal of a tiny, tiny number is large and positive, right? So again, if just to the left of pi over 2, cosine's small, like 1 over 1,000, so secant's a reciprocal of that, which is 1,000, which is way up here. So this is going to be an up cup, and same argument we did before, that's going to be a down cup. So here's your graph of secant x. Okay, so it has the same sort of flavor as the cosecant graph. Every pi over 2, something happens. We have vertical asymptotes, we have up cups and down cups. Now what's the difference here? What do you have to remember about the secant graph? On the secant graph, the up cup straddles the y-axis. It crosses at 0, 1, just like cosine. Now, it alternates point, asymptote, right? Asymptote, point, asymptote. You just have to remember that on the y-axis, the cup crosses. So the cosecant graph had a vertical asymptote, the secant graph crosses, has a y-intercept. Again, what do you think the period of the secant graph is going to be? The basic secant graph. Again, you need a down cup and an up cup. So from -3 pi over 2 to pi over 2, I get both my cups. That's a total distance of 4 pi over 2, or 2 pi. And how many pieces? Half the down cup, half the down cup, half the up cup, half the up cup. 4 pieces. Okay, so for sine and cosine and secant, cosecant, the period of the original graph is 2 pi with 4 pieces. For tan and cotan, the period was pi, and I used 2 pieces to graph. Okay, so again, to construct this from scratch, every pi over 2, something important happens. On the y-axis, the secant graph crosses at 0, 1. So you know there's asymptote on either side at the next important place, and then a point, the top of the down cup after that. Okay, so you just have to know how to construct these basic graphs. So we've talked about the basic parent functions for all 6. And now we want to sketch doing some of our translations. So the example here says, sketch the graph of y equals negative cosecant of 1/2 x plus pi over 2 over 1 period interval. Okay, so the procedure is exactly as before, right? We want to identify all the parts of the graph, all the features of the graph. And so what was the first step in the procedure? The first step was if you have a period change and a horizontal shift, you need to check for factoring. We have a horizontal shift and a period change. We need to factor the 1/2 out. Notice there's a half to pull out here, so I'm left with x. Now there is a 2 in the denominator to factor out, so that comes out and you're just left with pi. There's no adjusting like we've had to do before. Always check your factoring by remultiplying. Half x is half x, half of pi is pi over 2. Okay, let's identify everything. Now again, there's no amplitude here. Remember, the amplitude is how high the graph or how low the graph. So, but this number in front, the coefficient tells you something. Remember, when we had a sine graph, you know, like this, remember, like if I had y is 2 sine x, that distance was 2 and that distance was 2. So if this were 2 cosecant x, notice the cosecant, the cup is going to be here and the cup is going to be here. There's still a distance involved. So this 2 here tells you how far the cup is from the x-axis. So that's not, it's the amplitude of the sine graph. It's not the amplitude of the cosecant graph though. So I'm going to call that height, just to call it something. So the height here is 1. Okay, so where you found the amplitude for sine and cosine, that's where I'm getting the height number. Now the negative here means reflect because it's being multiplied, reflect. Okay, now what about the period? Okay, now how do we get the period of secant, cosecant? Just like the other 4, it's the old period divided by the number b, where b is the coefficient of x. So the period of the cosecant graph, the original one, is 2 pi. divided by the b 1/2. Be careful, don't multiply, you're dividing. And 2 pi divided by 1/2, when you multiply, you get 4 pi. Now what about the pieces? Just like we did with sine and cosine, we're taking a fourth of the period, which is pi. Okay? And then we have a horizontal shift here, a phase shift of how much which way. Okay, don't get it from here. We had to do the factoring. The whole point of the factoring was to get the horizontal shift correct. It's pi to the, we're adding pi, so it's to the left. It's the opposite of what you think. Right, so just like before, so what I'm calling the height here is the absolute value of the coefficient of the trig function, 1. The negative here means reflect. The period is 2 pi, the original period, divided by the coefficient of x, which is 4 pi. You get the pieces, you take a fourth of the period, pi, and the horizontal shift is pi to the left. Okay, so let's do the sketch. So I know the height here, 1, that's going to be important. That's where your cups start. And then the next step is do the horizontal shift. Notice the shift and the pieces are exactly the same here. So I don't have to leave a lot of room, right? If the shift is like 3 pieces, you have to give yourself room. The shift and the pieces are the same, so I'm just going to move pi to the left, say here, minus pi. Then from your shift point, you add or subtract pieces. Again, I'm making the numbers work out nicely here, so if I add minus pi, if you add a piece to that, I'm back at 0. Add another piece, I'm at pi. Add another piece, I'm at 2 pi. I'll add another one, 3 pi. Okay, so I have 4 pieces, 1, 2, 3, 4. Remember, for sine, cosine, secant, cosecant, you need 4 pieces for the period. And notice from minus pi to 3 pi is a total distance of 4 pi, which is what I said the period was. Now we're ready to construct the graph. What does the original cosecant graph do on the y-axis? The cosecant graph has a vertical asymptote, but that got shifted to the left pi, so there's my vertical asymptote. Right? So it's going to be asymptote, point, asymptote, point, asymptote. Okay? Now on the original cosecant graph, right, we had the vertical asymptote on the y-axis, and just to the right of that was the up cup. So that got moved to the left, so here's my vertical asymptote. Just to the right of that would be the up cup. However, we reflected, so now it's the down cup. So it's going to be like this. And then the up cup is here. Okay, let me do that one more time. Remember, the original cosecant graph has a vertical asymptote on the y-axis, and the up cup was right there. That got moved to the left, so this vertical asymptote got moved to here. The up cup gets moved to the left, so that would be an up cup here, except for we reflect, so it comes down there, so it's a down cup. Okay, so there's our graph of minus cosecant 1/2 x plus pi. Procedure is exactly the same, it's just you have to remember what your basic graph looks like. Okay, and then we have one more example to do, which is a secant graph. Okay, so this graph of the function is y is -3 plus secant of 4 times x minus pi over 4. Okay, what's the first step? The first step is check for factoring. We already have a coefficient of 1 here. The 4 has already been factored out, so we don't have to do that. Okay, now what about the height? What I'm calling the height here, the coefficient of secant is 1. Okay, there's no reflection. It's not the number out front, it's the number being multiplied by the trig function. That's positive, so there's no reflection. Now how do we get the period? The period of secant is 2 pi divided by the coefficient of x, which was 4. That simplifies to pi over 2. And then for the pieces, you take 1/4 of the period, because we're using 4 pieces, so that's pi over 8. We have a horizontal shift, phase shift, of pi over 4. It's minus, so it's to the right. Right, it's minus pi over 4, so we shift to the right. And notice we have a vertical shift. We're subtracting 3 from the whole expression there, so we're going down 3. Okay, so just like I did before with the vertical shift, I'm going to ignore that and do everything but that first, and then do a separate graph for the vertical shift. Okay, so I'm going to go down 3, so I need to leave myself some room to shift down. Okay, so the height is 1, so before the vertical shift, my cups are going to be touching at -1 and 1. Now what's next? Do the horizontal shift. I'm shifting pi over 4 to the right. Now how does the shift compare to the pieces? Pi over 8 is half of pi over 4, so one shift is 2 pieces. So when I shift to the right, pi over 4, I need to give myself a room for 2 pieces. So if I move pi over 4 to the right, that's 2 pieces of pi over 8. So this is pi over 8, right? That's 1 pi over 8 plus another pi over 8 is 2 pi over 8, which is pi over 4. And if I'm here at pi over 8, subtract a piece from that, I'm at 0. Again, I'm making the numbers work out. We keep hitting 0, but you don't have to. Subtract another piece, I'm at minus pi over 8. Subtract another piece, I'm at minus pi over 4. Notice I have 1, 2, 3, 4 pieces. From minus pi over 4 to pi over 4 is a distance of 2 pi over 4, which is pi over 2, which is what I said the period should be. Okay, so now I'm ready to sketch. I'm not doing the vertical shift. So what do you do at this point? Once you get your scaling done, you ask yourself, what does the original secant graph do on the y-axis? The original secant graph, you have a cup that straddles at 0, 1. But this got shifted to the right pi over 4, so this point goes over here. And we didn't reflect, so it stays there. So there's point, asymptote, point, asymptote, point. But remember, you alternate between up cups and down cups. So there's my up cup, which means the down cup is here. And then you're going to have an up cup here. So this is part of the up cup. Right? Normally I don't like to split my cups like this, but this is one period. I have half of the up cup, the other half of the up cup, and the entire down cup. Normally I would, now that I see what it is, I would add another piece here and finish that, but that's all right. All right, so this is everything but the vertical shift. This is secant 4 times x minus pi over 4. Okay, so now all we have to do is shift the graph down 3 and we're finished. Now the vertical asymptotes, if you shift that down, it's just in the same place. You may have to extend them, right, to make your graph look good. And we just need to go down 3. So let me continue my y-axis here. So 1, 3. So here's -2, -3, and -4. So if I move this point down 3, it's 1, 2, 3, it's here. And if I move this point down 3, it's 1, 2, 3, it's here. I move this point down 3, it's 1, 2, 3, it's here. Now this was an up cup, so this is still an up cup. This is a down cup, and then this is an up cup. I probably should have used a different color so we can see, but this is y is -3 plus secant of 4 times x minus pi. Okay, so the answer here, let me go over in black. So the answer is this cup, and this cup. Right, so I just took the graph I originally had and shifted everything down 3. So that's how you do the secant and the cosecant graphs.